Greetings, geometers. On this lovely day, we are going to be talking about conditional statements from section 2-2. One of our goals is to recognize conditional statements and their parts, and we're also going to write converses, inverses, and contrapositives of these conditional statements. So the first thing we want to be able to define is what is a conditional statement. And a conditional statement is sort of a funny definition. Any statement that can be written in if-then form with a hypothesis and a conclusion. The hypothesis is what comes after the word if, and the conclusion is what comes after the word then. So we want to practice today rewriting a statement as a conditional. Remember, at this stage, we are not going to talk about true or false. Now, it is important later, but right now we just want to take the statement and convert it. We're also going to underline the hypothesis, and we're going to circle the conclusion. So all cats have tails. All cats have tails. What we effectively are going to do is take the subject is cats and the predicate is have a tail, and we want to rewrite those into two different sentences, two different statements. So first off, I have to consider what family cats belong to. What kind of thing is it? So, for example, purple and yellow here are colors. A zot is a thing. A soda is a drink, etc. So down here, a cat, we would say something like this. If an animal is a cat, then it has a tail. Now, our hypothesis is an animal is a cat. And our conclusion is it has a tail. So notice I am not circling or underlining the if and the then, just the complete sentence. An animal is a cat is a complete sentence. It has a tail is a complete sentence. So this is my hypothesis and my conclusion. So let's look at the next one. Purple and yellow are complementary colors. So purple and yellow are colors. So I'll say if two colors are purple and yellow, then they are complementary. And now we can identify our hypothesis. Two colors are purple and yellow. And the conclusion, they are complementary. Now we can check our answers on these. Notice that C does not make sense at all, and that's okay because the point is not that it does make sense, but that I can convert this into an if-then statement. So there's something called a zot, so it's a thing. If a thing is a zot, then what is essential about it? It has a glurp. Drinking the soda will make you happy. If you drink the soda, then you will be happy. Lawyers must pass the bar exam. If a person is a lawyer, then they pass the bar exam. Fish live in water. If an animal is a fish, then it lives in water. Now, conditional statements can be either true or false. An example that shows a conditional statement is false is called a counterexample. So let's practice some counterexamples. If x squared equals 16, then x is 4. In other words, then x is only 4. And we say to ourselves, no, negatives can be squared to be positive. So x could be negative 4. So that would be a counterexample. Notice that a counterexample is not saying, no, that's false. It doesn't have to be 4. Oh, no, that's false. It doesn't have to be divided by 3. That's not what we're saying. What we're saying is give me an example where the first part, the hypothesis is true, but the conclusion is false. So if a number is odd, for example, 1, 3, 5, 7, then it is divisible by 3. And we say, oh, no, 7 is not divisible by 3. And when we mean divisible, what we mean is that it is becomes a whole number. If you visited a beach, like on an ocean, then you were in California, you say, no. It could be in Boston, or I could have been in Florida. All teachers are male. And All you have to do is find a teacher who is not male, and you say, oh, Mrs. McGillicuddy, or whatever. Now we're going to get to some logic part where we're going to be flipping statements and reversing statements. We're going to be using something called converse, inverse, and contrapositive of an original statement. So, first, how do we write these? Well, the first one we've already looked at, and this requires me to write it in if-then form. So I have if something, then something else. We'll get to the symbols in just a moment, and let's try this as an example. All animals breathe air. If an animal is a mammal, then it breathes air. And so we think about what's going on. Again, this right here, an animal is a mammal, is my hypothesis, and we can also call that P, just for brevity's sake. And it breathes air is my conclusion, but we often just simply call that Q. And the reason for that is because my if-then statement can be written as this: P with an arrow to Q. In other words, if you get to P, then you are forced to go on to Q. And we read this arrow as the word implies. So we say P implies Q. So in this case, an animal being a mammal implies that it breathes air. Or if I live in Boston, then that implies I also live in Massachusetts. So let's just analyze this real quick. Is this a true statement? If an animal is a mammal, then it breathes air. And we know that's true because that's one of the main characteristics of mammalization. Now, what about converse? I like to think about converse as reverse. What's that mean? Reverse. I'm going to reverse the P and the Q. I'm going to switch the P and the Q. In other words, Q comes first implies P. Implies P. So how does that look up here? If an animal is a mammal, then it breathes air. So what I'm going to do is switch the air and the mammal around. Notice I can switch all of this and say, if it breathes air, then an animal is a mammal. The problem is we usually don't start a sentence with if. If an animal breathes air, then it is a mammal. We think about that. An animal breathes air, then it has to be a mammal. And we say, wait a tick, that's false. Why? Because it could be a frog or a lizard, something like that. Next, inverse. I like to think about inverse as inserting a not. Insert the word not into the original statement. Into P implies Q. So, what's that look like with symbols? We're going to use this symbol like a tilde for the word not. So it's going to be not P implies not Q. So we go back to the original order. So don't converse first. Go back to the original order, PQ. So I'm going to say if an animal is a mammal, put a not here somewhere. If an animal is not a mammal, then it does not breathe air. Not a mammal, not breathing air. And we say, wait a tick. I know of mammals. I know an animal that's not a mammal that doesn't breathe air. For example, a frog doesn't have to. It's an amphibian. It's both. We could have originally up here noticed that an animal breathes air, then it has to be a mammal. No. Snakes. What do snakes do? Well, snakes breathe air, but they're not mammals. Or down here, a snake's not a mammal, and it breathes air. Okay? Now let's do the very last statement here. This last one, you're often going to get spell checked on because many dictionaries don't recognize this as a word, but it is in fact a word. Contrapositive is the longest word. So we're going to do the most to it. We are going to switch the statements, and we're going to insert. In other words, logically or structurally, we're going to take the converse of the inverse, or the inverse of the converse. So I say, if not Q, then not P. So all I have to do is take the inverse of this converse or the converse of this inverse. Doesn't matter. If an animal does not breathe air, like here, but I switched it, then it is not a mammal. Again, mammal and air, switch here. Or I inserted a not up in this situation. And notice here, if an animal does not breathe air, then it's not a mammal. That's true. That's true. So notice what we have here. We've got some connections. The trues here are both true. And the falses here are both false. Now, I'm not saying that all converses are false and all inverses are false, nor am I saying the original statements are always true. But I'm saying that when this is true, then this one also is true. When this one is false or true, then this one is the same. We call these two, this pair, logically equivalent. In other words, saying that an animal is a mammal, then it must breathe air, is the same thing as saying an animal that does not breathe air is not a mammal. So, for example, if I live in Boston, then I live in Massachusetts. If I don't live in Massachusetts, then I don't live in Boston. Because if I'm not in Mass, then I definitely can't be in Boston. And these two are equivalent. Whether they're true or false, it doesn't matter. It could be, if this is true, then these are both true. If this is false, then these are both false. Logically equivalent. All right, your job now is to go down here, and you're going to be doing the inverse, converse, and contrapositive of this original statement.